Hey guys, today we're going to be talking about angles, specifically looking at an angle diagram, having a little bit of information about those angles, and trying to figure out some missing values. And I guess in this first problem here, let's make our goal to find the actual angle measurement of ABD. So in this diagram, we have a total of 3 different angles, all 3 of which are designated right here. We have ABC, this large angle, the whole thing, ABD, this smaller one with this ray that's kind of intersecting with it, and then DBC, this other smaller angle. So the deal is that angles are very similar to line segments if you've worked with those. We can oftentimes split up an angle into smaller parts, or an angle will be split into smaller parts, and we can use some information about those to help us learn about the larger one, fill in some of those missing blanks. Now, on all of these little bits of information, you'll notice I have 5x plus 1 degrees, or 4x minus 1 degrees. Now that degrees sign actually applies to this entire thing. It's not just saying 1 degree, right? It's saying 5x plus 1 as a unit, degrees, because that's what angles are measured in. So I'm going to go ahead and try to figure out what I can do with this information. If I know this smaller angle up here, the top one, is 5x plus 1, my second angle is 4x minus 1, and that together, this whole thing is 45 degrees, maybe I can make an equation out of that that relationship that we see in the diagram. Well, these 2 smaller angles make up the larger one, so could I say that angle ABD plus angle DBC is equal to angle ABC? The 2 smaller ones add together to equal the larger one? Absolutely we can. That's a very reasonable statement to make. So I'm going to go ahead and plug in the information I know. ABD is 5x plus 1. DBC is 4x minus 1. And then ABC is 45. So we just have some terms to combine, some stuff to simplify and solve. Well, 5x plus 4x gets me 9x. 1 minus 1 gets me nothing. So I have 9x equals 45. And to get x on its own, we'll divide by 9. Now that tells me x is 5. Now does that answer my whole problem? Is this like 5 degrees or something? No. I wasn't looking for x as my final answer, right? Like I needed to find it, but that's not the goal. The goal was to find out what is ABD. So how can we use the information we found to figure out the answer to that? Well, right here we have ABD and we have a little equation that solves for it. Now that we know what x is, why don't we go ahead and plug it in? So 5 and then times x. Well, we just found out x is 5, so let's put that in there. So 5 times 5 plus 1. Well, 5 times 5 is 25. And 25 plus 1 says 26 degrees. That's what ABD is, a 26 degree angle. And that's that. We've solved our problem. So we're going to do one more example in this video, but I'm going to have a slight change, a slight additional kind of statement here. I'm going to include the statement that the ray BD is a bisector. Now you may be familiar with this term. A bisector means something that cuts, an angle, or maybe a line segment, or a lot of different things in geometry, honestly. But it cuts it in 2 exactly equal parts, what we often call 2 congruent halves, right? We use that word congruent a lot. So if BD was a bisector, then we could actually say these 2 angles are the same thing. They're identical. And we can represent that in terms of a diagram by putting these little angle marks there and then putting a tick mark on the angle. And by saying, well, I have this little tick mark here, and then there's this other angle with that same mark, that means they're the same. That means they're congruent. And if we know that's a bisector, we can do that. And that information is probably going to help us out when we try to solve this problem. So let's say ABD is, I don't know, 6x plus 2 degrees. And let's say DBC is, oh, I don't know, 8x minus 4 degrees. And we want to find out how many degrees is angle ABC. Well, if we know that BD is a bisector, we know that these are equivalent, then we could make a mathematical statement about that. We could write an equation. We could say angle ABD is equal to angle DBC. That seems reasonable since they're congruent, since they're the same, they're equal to each other. Let's plug in what we know. Well, ABD in this problem is 6x plus 2, and DBC is 8x minus 4. So let's try to solve it. Well, I'm going to move my stuff around. I'm going to move 6x to this side, cancel that out, get 2 equals 8x minus 6x, or 2x minus 4. And then I will add 4 to get x on its own. So that's going to get me 6 equals 2x. And then we'll just finish up that problem by dividing by 2. So I get 3 as my value of x here. Now yet again, I've got my value of x, but does that tell me what I want for my answer? Not quite, yet again. We want to know what is ABC. So we have to ask ourselves, how does x help us with that? Well, obviously we can plug x into what we know, but what does that do for us? Well, if we know this is a bisector, meaning they're 2 equal halves, if we plug x into one, it should be equal to the same as the other one, right? If they're the same, it should be equal. And then this larger angle is a combination of the two, so we should just be able to add what each of these smaller angles is. So let's try this out. Let's plug in 3. So 6 times 3 plus 2. Well, 6 times 3 is 18, and 18 plus 2 gets us 20. Now, if we did it here, we should get the same thing. 8 times 3 is 24. 24 minus 4 also gets us 20. So we know ABD is 20 degrees, DBC is 20 degrees. So together, they form an angle that is 40 degrees. All right, that's how we solve some angle problems. We're going to have another video that talks about some angle vocabulary, kind of like this, whenever we say, this angle is so-and-so, right? Complementary, supplementary. I know, just a little teaser of what that other video is going to be about. But we're going to talk about solving some angle problems with those involved as well. Keep an eye out for that. But if you have any questions about this, feel free to drop them below. Otherwise, thanks for watching, guys.